Today we're going to look at something called logarithms. So far this chapter we've looked at exponential functions and we know two ways to solve. You can find a common base or use guess and check. Today we're going to go over the mathematical way that you can solve for an exponent. So the warm-up, most cars depreciate as they get older, and what that means is they go down in value. Suppose a car you buy for $14,000 depreciates in value by 1/5 every year. Write an exponential function that represents the situation. And then when is the car worth half of its value? So if we write an equation, we're going to start with y equals, and for exponential growth or decay, we're going to start with 14,000, our starting value. And it's depreciating or going down by 1/5 of its value every year. Let's change that to a decimal. 1/5 is 1 divided by 5. Justin, could you shut my door for me? Oh, thanks, Lacey. So 1 divided by 5 is 20% or 0.2. So what that means is the car is going down 20% a year. So in our equation, we're going to start with the 1. We're going to subtract the 20% per year, and we're going to take it to the x power. So again, we start with 100% of its value, and it's going down 20% a year. So 1 minus 0.2 will be 80%. So here's what the equation looks like. Y equals 14,000, and then 0.8 to the x. So what this means is that every year it retains 80% of its value. So the question is, when is the car worth half of its value? So if we set up the equation, we're going to start with 7,000, and that equals 14,000 times 0.8 to the x. And then from here, remember there were two ways we knew how to solve, guess and check, or finding a common base. So for this one, if we use guess and check, we could type in values of x and figure out when does this side equal 7,000. Today we're going to go over a faster method to solving. Before we do that, let's review. On your test, I would give you something like this, solve, and I wouldn't tell you if it's a power function or exponential. So let's take a look at the difference between the two. A power function has a number in the exponent, and an exponential function has an x in the exponent. So you solve them two different ways. In a power function, you do opposite order of operations. We would take this to the 4/3 power. So this would be x to the 4/3 power. This would be 20 to the 4/3 power. Exponential, again, there's two ways that we know how to solve, guess and check or finding a common base. If we find a common base, this is the same as 2 to the 3rd power, and we see that if the bases match, then x must be 3. We need something to undo an exponent, so today we're going to look at these exponential functions. What's another way to solve? A logarithm undoes an exponent. Logs and exponents are inverses of one another. So let's take a look at how we use them. The first step is we have to be able to change an exponent to a log. So this is the exponent form, b is the base, x is the exponent, equals a. Here's what the equivalent log form looks like. Alright, so let's practice writing this. So when you write a log, you always write log first. Then you look for the base. The base is the big number with the exponent. So we say this is log base 4, and it makes a loop. Log base 4 of 64 equals 3. Alright, so there's one way to write it. Let's try another one. What's the base of this right here? It's 3. So we're going to say log base 3, and we're going to make our loop of 1 over 27 equals -3. And these are equivalent forms. Let's go backwards. What's the base of this log? It's 125. What's the exponent? Make a loop. The exponent's 2/3, and that equals 25. And if you type that in your calculator, 125 to the 2/3 power is 25. Let's try another one. What's the base of this log? It's 8. The exponent, we make a loop. It's 8 to the 1/3 equals 2. And again, if you type that in your calculator, 8 to the 1/3 power is 2. Alright, so how does that help us? In our calculators, if you have an Inspire, we're going to type it in this way. But if you have your phone or some other calculator, scientific or a regular graphing calculator, when you type in a log, here's how you're going to solve it. So we'll practice going over that. If you have your graphing calculator, it's really easy. Here's how we're going to do it in class. Alright, so let's go over how we would solve. Let's practice solving exponential equations with logs. Here are the steps. Identify that x is the exponent and that you have an exponential function. You have to use logs to solve. Use algebra to get the base by itself, the base and the exponent by itself. Change from exponential form to log form and identify the base b and a. Type them correctly into your calculator and you should have the answer. So let's solve for the first one. It's exponential. You can use guess and check, common base, or now logarithm. Second step, put it into log form. It's log base 4 and then make your loop of 128 equals x, and then you type it in your calculator. So on the Aspire, here's what it looks like. We're going to hit Control 10 to the x to get our log. Whoops, let me go to Scratchpad here. Okay, so Control 10 to the x. There's the log. The base was 4, and we say of 128. If you hit Enter, we get x is 3.5. So here it is, x is 3.5. You can check your answer by typing in 4 to the 3.5 power. We should get 128. So 4 to the power of 3.5, and we should get 128. Okay, now let's say that you're at home and you didn't have a graphing calculator on hand. You can still use change of base to type this in. So this in a calculator on a phone, you're going to type log of 128, so it's log of the second number, divided by log of the base. And when you do that, check your answer. You should get 3.5. In some phones or calculators, you have to type in 128 log, hit enter, and then divide by 4 log. So it depends, but it should be log of the second number divided by log of the base. All right, let's go over example 2. First step, get the base and the exponent by itself. So we're going to divide each side by 4. We get 10 to the x equals, let's type this in, 4650 divided by 4. Oops, I should try that again. 4650 divided by 4. So 1162.5. Alright, let's change this to log form. So this is log base 10, and oftentimes you'll see log base 10 as a common log, so they'll just write log. They'll write log base 10 of 1162.5 equals x. Notice x is by itself. If you have everything on one side, you can just type it right into your calculator. So let's do that. Log base 10 of 1162. Or I can use the last answer key. I should do that. So instead of typing this in again, I can hit Control negative, and it will type that in for me. And here's our answer, about 3.065. So x is about 3.065. Okay, let's try it with word problems. So this is the warm-up. Most cars depreciate in value as they get older. Suppose you buy a car for $25,000. It goes down 1/5 of its value every year. Write the exponential function. And when is the car worth half its value? All right. Well, half of 25,000 is 12,500. That equals 25,000 times the 1 minus the 20% per year, and x is number of years. Let's get the base and the exponent by itself. Let's divide each side by 25,000. So you get 0.5 equals, and 1 minus 20% is 80%, or 0.8. All right, you can use guess and check. You could try to find a common base. Let's use logs. So this is log base 0.8. Again, I know that because x is the exponent. Make your loop. 0.5 equals x. And then you just type that into your calculator. So here's what it looks like. 0.8, 0.5. And after about 3.1 years, your car is worth half of its value. Again, if you're trying to type this in your phone, you'd probably want to do log of 0.5 divided by log of 0.8. But in the Inspires, it's pretty easy just to type it in. Okay, 2 more examples. An initial deposit of $500 is invested at 8.5% interest compounded annually. That means once per year. How long will it take until the balance grows to 800? Use this formula. So we have 800 equals 500. The interest rate's increasing, so you have 1 plus 0.085. That's 8.5% as a decimal. And x is time. Let's use a logarithm to solve. We'll divide each side by 500. So we have 800 divided by 500. 1.6. 1.6 equals 1.085 to the x. Let's use the log to solve. Log base 1.085, make your loop of 1.6 equals x, and type that into your calculator. So log of 1.085 of 1.6, about 5.76 years to get $800 in this account. Last one. The common log has a base 10. The common log is used to measure acidity, sound, and earthquakes. Whether a log is written without a base, or when a log is written without a base, the base is 10. So whenever you see a logarithm, there's an invisible number here, it's base 10. And let's rewrite this in exponential form. The base is 10. 10 to the power of 4 equals 10,000. And you can check your answer for that. Okay, so there are some examples of logarithms and how you use them to solve.